Everyone, in the last lecture we studied about what do you mean by arithmetic progression, the definition of the arithmetic progression. Then we studied about the first term, common difference. Then in further we studied how to get the general form of the arithmetic progression, and we solved few problems on that. Now in the today's class we're gonna see how to get the nth term of the arithmetic progression. Okay. So to explain, to get the nth term, I'll take one small example. I'll explain that example how to get the nth term. Then we'll get the nth term of the arithmetic progression using the series. Okay. So I'll consider here even number series. So we all know the even number series. It is nothing but 2, 4, 6, 8, so on. Okay. Here, since it is the given series, let's check whether it is the given series is arithmetic progression or not. So, first term a is equals to 2 and common difference d is nothing but 4 minus 2, it is 2. And the given series is arithmetic progression because by seeing it I can find the consecutive numbers difference is 2. Okay. Now what I have to do, I'll assume the first term, second term, third term, and I'll represent in a slight different manner. Okay. So what is the first term? I'll keep the first term as it is. Second term, first term is 2. I'll keep it as it is. I'll not do any changes. The second term will be 4, which is equals to 2 plus 2. Okay. And further I can write it as 2 plus 1 into 2, which further I can write it as 2 plus 2 minus 1 into 2. Okay. All these are same. Okay. So 4 is nothing but 2 plus 2. I can write 2 plus 1 into 2. I can write 2 plus 2 minus 1 into 2. So this all gives me the same answer. Similarly, I'll take the third term. It is nothing but 6. I can write it as 2 plus 2 plus 2, which further I can write it as 2 plus 2 into 2, which further I can write it as 2 plus this one I'll write it as 3 minus 1 into 2. Again we're getting it as the same number I'll get. Similarly, I can keep on writing this till as many times as possible. Let's see what I'll get at the 15th term. Okay, 15th term is nothing but 14th term plus 2. Correct. So what I'll do, it will be 2 plus 2 plus 2 plus 2 plus so on till 13 times plus 2. Okay. Further, it is nothing but what I'll get. I have to write again in this form, right? It will be 2 plus 2 plus 14 into 2, or I can write it as 2 plus 15 minus 1 into 2. Okay. If you calculate this one and this one, it will come same. Okay. This is how we're going to calculate by splitting up of the numbers, by taking the common or by multiplying it. We're going to split like this and we're going to write. Now, we're going to keep this method as a base method to get the nth term of the arithmetic progression series. Okay. Now, this example what it is showing is for the even numbers. I have taken only even numbers. Let's say I have some other series and all. For that I cannot keep the thing in the series in the reference, then solve like this, then find the 16th term or 15th term. No, I cannot do like that, right? I have to have some standard form wherein there I can directly substitute and I can directly find. So that I can be saving the time. So for that, what I have to do, I have to consider the arithmetic progression series. So let's consider, let A1, A2, A3 be arithmetic progression, and we know the general form of the arithmetic progression. In the last lecture we studied how to get the general form of the arithmetic progression. So now general form of AP is A plus D, A plus 2D, A plus 3D, so on. Correct. Now here the first term is A. Second term is A plus D, which I can write according to the previous example method. I can write it as A plus 2 minus 1 into D. Okay, because here nothing is there, I can consider it as 1. 1 I can write it as 2 minus 1. Similarly, I can write for third term A plus 2D, which is nothing but A plus 3 minus 1 into D. So like this, I can keep on writing for the fourth term, fifth term, so on. Now, let's say at the nth term, okay, at the nth term, it will be A plus n minus 1 into D. Okay, and this is the formula for the nth term of the arithmetic progression. So what I have done, I have considered the arithmetic progression series, then I took the general form, then I split the each term like means for the first term, for the second term, for the third term, I split it. So that further, so as the series goes on, I can keep on writing in this method. So finally at the nth term, I got it as an plus n minus 1 sorry, A plus n minus 1 into D. Therefore, I can write it as the nth term an is nothing but A plus, that is A is nothing but the first term, and with the common difference D. And which number you want to find, okay, that is nothing but n. So here n is nothing but 1, 2, 3, so on. N can be any number. It can be 15, it can be 25, it can be 36, or it can be 99. It can be any number, okay. So now this is the this is the nth term of the arithmetic progression. So we will represent the nth term as an, and it is a combination of first term and the common difference, okay. Now this is the formula for the nth term. Now let's see how to solve the problems to find the nth term of the arithmetic progression. So we know the nth term an is equals to A plus n minus 1 into D. So now we'll take one simple straightforward problem in which we have the common difference in the first term, and they've told us to find some let's say 15th term. We'll see how to do that program. So given that first term is 7 and common difference is 2. Find 15th term. Okay. So this is the question. What I have to find? I have to find the 15th term. That is nothing but 15th term is A15 I have to find. What in our data they have given to us? They have given us A. The first term they have given, that is nothing but 7. They have given us the common difference, that is nothing but D, that is 2. And we have, and with the 15th they have given, that means they have given us the N. Therefore, N is equals to 15. Okay. So therefore, by substituting into the formula, we have to see what answer we're gonna get. So therefore, A15 is equals to, what is A? A is 7 plus N is 15. 15 minus 1 into D is 2. So A15 is equals to 7 plus 14 into 2. 7 plus 28 is equal to 35. Therefore, the 15th term of the series will be 35, whose first term is 7 and the common difference is 2. This is one of the simple problem. I'll explain once again. If they have given us a question that we have to find the 15th term of the AP. So now what data they have given us? They have given us A and they have given us the common difference D, and with that they have given us N. So now what I'll do, I'll take this all the data and I'll substitute in the given formula and I'll obtain the answer. Okay, I hope you guys have understood this. We'll move on to the next problem. Now we'll take an arithmetic progression, then we'll see how to find the given respective term. Okay. Okay, they have given us an arithmetic progression. Find 11th term. So sorry, they have given us one series. For that they have told us find the 11th term. Now here they haven't mentioned anything whether the given series is arithmetic progression or not, and what nth term formula we have found. It is for the arithmetic progression. So therefore, first we need to find whether the given series is arithmetic progression or not. Okay, first we'll verify that, then we'll see whether we can find the nth term or not. Okay, so they have given us this series, so whether we have to find the given series is arithmetic progression or not. Okay, so for that what we have to do, we have to find the consecutive difference. Correct, the difference between the two consecutive terms we have to find. So therefore 5 minus 2 is equals to 3. 8 minus 5 is equals to 3. Okay, and I'll take one more term. 11 minus 8 is equals to 3. So all the three has the same constant. Therefore the given series is arithmetic progression. Okay. So now similarly by simultaneously I have found the value of the D also. Therefore D is equals to 3. And what is the first term? A is nothing but 2. And they have told us to find the 11th term. Therefore N is equals to 3. Now we'll substitute the found data in the following equation formula. An is equals to A plus N minus 1 into D, where An is nothing but A11, A is 2, N is 3, sorry, N is 11, sorry, 11 minus 1 and D is 3. So A11 will be 2 plus 10 into 3. A11 will be 32. Okay. So this is the answer you will get. Now I'll explain once again. So they have given a series and they have told us to find the 11th term. They haven't mentioned whether the given series is arithmetic progression or not. If they have not mentioned it, first try to find whether the given series is arithmetic progression or not. If it is arithmetic progression, then collect the required data and substitute in the formula and you will get the required term. Okay, so this is I hope you guys have understood this. We'll move on to the next program. Next category problem, we'll see how to solve that. In this problem, they'll be giving you the some particular two different terms and with their values, and you have to form some linear equation and then you have to form the arithmetic progression series. That type of problems also they will be asking to you guys. Now let's see the problem. Determine arithmetic progression whose third term is 5 and seventh term is 9. Okay, so what I have to do in this problem, I have to find the arithmetic progression using the third term and the seventh term. So I have the value of the third term and the seventh term, and I have this equation. Using this equation, I have to find the rest arithmetic progression series. To find the arithmetic progression series, what and all data are required? To find AP, I need A and I need B. So now I don't have both A and D. So using this data, I have to find A and D. Then I can form the arithmetic progression series. Now let's see how to find the A and D. So now what is the first data we have? Third term, that is nothing but A3 is 7. And what is the second data I have? Seventh term. Sorry, third term is 5. This, and I have the second data is seventh term. And the seventh term is A7, that is nothing but A7, and I have the value as 9. So now what I have to do? I have to form the equation. From this, I'll get it as 5 is equals to A plus 3 minus 1 into D, according to this equation. And in the second one, I'll get it as 9 is equals to A plus 7 minus 1 into D. So further if I write, I'll get it as A plus 2D is equals to 5. A plus 60 is equals to 9. Okay. So these are the two equations I am getting. This is equation, one second. So this is equation 1, this is equation 2. Okay. Now this is equation 1 and equation 2. We're going to solve the equation 1 and 2. Okay. 1 and 2. After solving, what we get? So A plus 2D solving 2 and 1, we'll get A plus 60 is equals to 9. A plus 2D is equals to 5. 4D is equals to 4. Therefore, D is equals to 1. Okay. I found the value of D. Now I have to find the value of A. Therefore, A plus 2D is equals to 5. A plus 2 is equals to 5. A is equals to 3. Because this term goes this side, I'll get it as 3. Now I have found A and D. Once I find A and D, I can easily write the arithmetic progression. Okay. Therefore, arithmetic progression is. So I have a general form, right? First I'll represent that. A is equals to A plus D, A plus 2D, so on. Okay. So I can write it as 3, 4, 5, 6, 7, so on. So now this is the arithmetic progression what we have to get by using these two data. So finally I found the series. So I'll explain once again. In the given question they have told us to find the arithmetic progression whose third term and the seventh term they have given, and the third term is 5 and the seventh term is 9. Using these two data I will be forming two linear equations. After solving these two linear equations, I will get the value of A and D. So, to find any arithmetic progression series, it is very important to find A and D. Once I find A and D, then I can substitute that A and D value in the general form. Then I can easily write the arithmetic progression series. I hope you guys understood this problem. So, in the next class, we're going to see the sum of nth term method, and that will be the last topic according to the syllabus. We'll see in the next lecture and we'll solve few problems on that. Thank you so much.